the last video about theory and with inverses. And so we're going to do the same thing with the tangent and the inverse tangent. And just to make it go a little quicker, I'm going to go right into Desmos. I think Desmos is a really good way to see these things. Okay, so here's the graph of the tangent. And notice how we want to find, it just repeats itself over and over again. Again, we've looked at this before, and it's just dizzying. And we showed that it had asymptotes at x equal pi over 2 and x equal minus pi over 2. And lots of other places too. I'm just putting those down. So I want to do it. So we want to find one part of the graph, one section of the graph that is both 1-to-1 and has all the possible tangent ratios. And notice we showed this before, but I want to, when we had the Visio on the tangent, but the tangent ratio can be anything, any real number. So in other words, it goes between minus infinity and infinity. Just a horrible typer, and I apologize. Okay, so we want to have every possible ratio, so we need the graph that goes everywhere. And again, just to zoom out, you can see the graph just keeps going. Okay, this isn't that useful on Desmos because of the scaling. Okay, so it's pretty clear that if we want to get one section of the graph, we just go between minus pi over 2 and pi over 2. So let's do that. So we're going to do the tangent function, and we're going to go between minus pi over 2 and pi over 2. So bracket minus pi over 2 oops, sorry, we're going to be here. Less than or equal to x. Didn't need to have that there. And less than or equal to, what's going on here? Less than or equal to, I keep hitting the wrong button, pi over 2. By the way that I get that less than or equal sign is I do option less than or option greater than. Okay, so now you can't, so we just want to get a part of the graph, but again, it's going to be kind of, well, no, you can actually see it really, really well. Sorry, I don't mean to keep doing that. Okay, you can see it really well that it's just going to cover, that blue part is just one cycle. That's all we need. So we're just going to do that. That's going to be our tangent. And so we're going to flip that over. And I'm just going to notice here, and we'll go back to the paper and write this down in a second, but that tangent ratios can be any real number between infinity and minus infinity. And this branch, sorry, we want to make sure this is a note. In this branch, the angle is between negative 90, or pi over 2, and 90 degrees. So we're going to go back and do our work. Okay, so let's stop the share, and then we'll come back to it. Okay, so here's what we decided. We're going to invert this part of the tangent. And then we have, here's our ratios. And again, we plug in an angle, and we get back a ratio. The ratio can be between minus infinity and infinity. We saw that in a different video. The angle can be between minus pi over 2, but it can't equal that because we got 1 over 0 for our ratio, if you remember, and pi over 2. Okay. So when we look at the inverse tangent, which is called the arctangent, we're going to kind of flip this over. The biggest, we're going to get back, again, I like doing this. We plug in an angle, and we get back a ratio. So here, we're going to put in a ratio. And that's going to be, our ratio, again, as we notice here, can go between minus infinity and infinity. Okay. And our angles our y-coordinate is going to be between pi over 2 but not equal to it and less than pi over 2. I mean minus pi over 2. By the way, I made a mistake here. I had less than or equal to infinity, and infinity always gets the strict inequality. So my bad. Okay. So our graph is going to be between y equals pi over 2. These become horizontal asymptotes. They were vertical asymptotes in the graph of the tangent, and the inverse tangent, they're going to be horizontal. And what's going to happen is we know we got 0, 0 for here. When our tangent ratio is positive, our angles are between 0 and pi over 2, so it kind of levels off. And the same thing here. So you see that they're horizontal asymptotes. So that's what the inverse looks like. Okay. And so let's go back and do a share, just to kind of graph it on Desmos. Okay. So there is our graph of the tangent. So let's look at the tangent function, inverse tangent, tangent, minus 1 for inverse, x, and let's put in horizontal asymptotes, y equals pi, and I know it's right now it's going to look pretty ugly, but we'll clean it up in a second. Okay, and I want this to be dotted, and red's a good color, not like purple. No, sorry, we're going to use, let's we decide to use red, and here I'm going to use red too. Okay, the graphs are pretty ugly, so let's turn off the tangent. Now we have the inverse tangent, and as you can see, it's exactly like we pictured it. It's going to go between y equals pi over 2 on top, and y equals minus 2 on the bottom. Okay, so I'm just going to summarize that, and then we'll be done. So I'm going to stop the share. Okay, so summary. Here's the inverse tangent. Also known as the arctangent. X is a ratio. Y is an angle. Okay, so the graph looks like this. We have a horizontal asymptote on the right at y equal pi over 2, and one at the left at y equals minus pi over 2. Our domain here, which are the possible ratios, are going to be all real numbers. And the range, which are going to be the angles, are going to be between minus pi over 2 and pi over 2. And finally, we have horizontal asymptotes at y equal pi over 2 and the horizontal line y equals minus pi over 2. Okay, so, I think I might as well summarize. No, I think that's good. I think that's a good place to stop. Okay. So again, we'll go on and do practice problems next.